So, as I said before, this Prometheus series will look at great works from different fields, try to think about them, what makes them great, and what lessons are there for us to take from these great works. We've talked about some things in art, advertising, literature. Today, I want to take that to the area of invention. And we will think a little bit about great work and inventions, the fascinating processes of invention. When do we consider inventions to be great? And which inventions are that great? And why do inventions happen? And how does it turn out that these inventions come into being, that they become acknowledged as great works, as achievements? Necessity is the mother of invention. Well, this is what they say, but I will ask, is it really? If you want to look at the real invention in the sense that people think of inventions, like bringing something new, completely new, does it really come from necessity? Maybe not all the time. You'd be surprised. Which necessity? The necessity dictated by whom? And this story in particular, the connection between great work and inventions, particularly by looking at the steam engine and connecting that to a number of other inventions, to the story of the Industrial Revolution, and reflecting on how some of these things happen. Our exploration today in this episode will take a look at change, networks, attunement, opportunities, and systems, and how all these things come together in order to make inventions recognized as great works. So we will look at the steam engine, at James Watt, at the relevant processes, but we will also look at other inventions and we will try to make sense of the whole story. Again, not from the technical perspective, but from the perspective of work and from the perspective of acknowledging great work and great achievements. So let's dig into this. Who invented the steam engine? We'll start from this question and then elaborate a little bit and see what it means. So myth has it, and I've read this in a couple of places, and this is when I wanted to research further. So myth has it that James Watt was sitting at home near the fireplace or the stove or the earth. You have it. And he saw the tea kettle, and the water was boiling in the tea kettle, and the cover was moving. And this is where he got the idea for the steam engine. But this is the myth. This is not the reality. Who invented the steam engine? If you dig deeper, if you do some more research, you will find out that James Watt did not invent the steam engine. His role actually in the story of the invention of the steam engine was to improve the efficiency of an existing steam engine design that was done by somebody else called Newcomen. Okay, and this is very important. Improve the efficiency of the design. So Newcomen had designed a steam engine, but that steam engine wasn't very good. It wasted a lot of energy, and the role of James Watt, he was hired to improve that, and he did. He improved it by relocating the condensation cylinder, saving a lot of energy, and so making the existing design more practical for industrial use. Again, other than efficiency, this is a key word, more practical for industrial use. So it was the Newcomen engine. Newcomen invented the steam engine. Well, not really. Okay, so even before Newcomen, there were many people who worked on that. So there was, in 1698, Thomas Savery. He actually patented a steam-powered water pump. Okay, so this is a steam engine. It's a steam-powered water pump. They used it in the mines, right? Okay, so was it Mr. Savery? No. You can go back more and reach Edward Somerset in 1662. He was the Marquis of Worcester, and he published a book containing several ideas, and one of them was a steam-powered water pump, okay, to supply water to fountains. Whoa, great, we found the inventor. No, it wasn't him. You can go back further. And in 1606, there was a Spaniard named Geronimo de Ayans y Beaumont. Okay, and he was even granted a patent for a steam-powered water pump that was used to drain the mines of his area of Guadalcanal in Spain. Okay, Wow, great. Okay, we finally reached the no. Again, you can keep going and going and going, and there are all these layers of inventors till you reach Hero of Alexandria, right? And this was thousands of years ago. So who invented the steam engine? Well, you can keep on going with people who created the idea. You might find the source of the idea somewhere buried, somewhere deep in the past. But the question is, if we say that Hero invented the steam engine, and he did, you can look at a design of his and see that this is the principle used in the steam engine. But the question isn't here. The question is, what would Hero in Alexandria thousands of years ago do with the steam engine? Right? What would the steam engine be used for? Is it a party trick? Is it something to be placed in a temple somewhere to demonstrate the power of the gods? I don't know. But it's quite tricky. Also, uh, inventions need inventions. So who will use Hero's invention? Who will improve on Hero's invention? Who will put it into practical application again at that time? Who was inventing things other than Hero? I don't know, but probably not many people. So this is a very interesting story. There are many parts to it. At the time of Hero, when we have the first recorded view of this concept of the steam engine, this thing is a novelty, right? It's something for fun. It's not hasn't been invented out of necessity at all. It's just somebody playing with different things and he came up with it. But it takes time. It takes other inventors. It takes a system to start putting that into place. And this is what we will talk about in the comic section. So you might think, wow, strange, this story of James Watt, this story of attribution. But turns out this is not a strange story in the sense of the word. This is not a unique story. This is something that keeps happening over and over. And now I can tell you about a few other inventions and their attributions, and you will find out it's almost the same thing. So the the Wright brothers did not invent the airplane. There was actually somebody 2 years before them who had a flight. It was for a specific period of time and so on. But what they did was it was unique in the sense that their flight was heavier than air machine, and it was controlled to a different degree. You can say the same about the light bulb. Look at all this list of items. The printing press. All of these items had ancestors, so to speak. But we have one particular inventor who comes and makes it more practical or more applicable in a sense, or improves on the design enough so that the design becomes useful to a mass of people, right? So somebody taking an idea that is almost there and giving it to a wider population, giving it to more people. And this is the catch that we saw in the case of the steam engine, making it more practical, more applicable, more efficient, right? So inventions happen frequently, gradually, step by step, but we have to keep something in mind. The idea here is that in order for inventions to happen organically, continuously, and in a large volume, you need to have funding, you need financial resources, you need to have enough financial resources, because invention takes a lot of experimentation. And this is the famous quote by Edison, and trying 1,000 times to invent the light bulb. Well, you can qualify that statement, but in order for a system of inventions to work, and you need systems of inventions to work, you need investments, you need to be able to take losses, right? This is the Darwinistic view. We need all these people trying, all these inventions coming to life, but then some of them aren't very practical, aren't very useful. And if it isn't very practical and it isn't very useful, then it incurs some kind of loss. And you need somebody to be able to take that loss on the short term to see what happens on the long term. Okay, so this is the Darwinistic view of loss. Continuous versus radical. Most of the inventions are improvements on already existing models. If it completely comes out of the blue, then it will be like hero's engine, right? It will be a novelty, it will be a trinket. of some sort. But the utilitarian view says, well, you need to make something practical enough to be adopted by a large enough number of people, and you need to do it in a way that it can fit within the existing social structures. So this is the question I asked in the previous section. What would Hero in Alexandria do with a steam engine? This has a completely different answer than what would an improved steam engine by James Watt help in, right? At the time of the industrial revolution. So efficiency, and there is this threshold of utility. We need to keep improving inventions till they become very useful to a particular group within a particular social and economic context. And this is what takes us to the point on great work, right? For your work to be considered, to be accepted as a great work, it needs to fit with a particular group of people at a particular point in time, right? So it needs to meet the standards, meet the requirements of efficiency. And you can hear contrast between incremental improvements, between improvements that utilize existing products and existing systems and existing structures, and completely radical ideas that come out of the blue that will face much more resistance and that will find real difficulty in being connected to the right applications. So from this point we can go up one more level of abstraction, one more level of awareness, to use the Atlas terminology, and think about the issue of heroes, systems, and networks in general. So start from the steam engine, talked about inventions, but now I want to talk a little bit about heroes versus systems. So the invention of the steam engine happened in the context of the Industrial Revolution. And the Industrial Revolution in Europe was a set of economic, social, and cultural conditions that were changing all kinds of relationships, all kinds of structures. And it had a very interesting flow across Europe. If we look at the graph that shows the spread of the Industrial Revolution, it's actually very interesting. It happens in waves. And it seems that it is sort of a spirit of the times, right? A spirit of the times that is being propagated with time across Europe. And here we can start thinking about networks, right? So there are networks of creativity. These inventors come together, one of them improving on the ideas of others and so on. But there are also networks of adoption. So we have this invention, okay, where will we use it, right? And this is the question we asked: what would Hero do with the steam engine, Hero of Alexandria? So we have these networks of transportation and we have these networks of communication, and in establishing these networks in the context of the Industrial Revolution, we can more deeply understand the duality between creation and adoption, right? It's not enough to create. You need to have the right people who are able to use this, to put this into practical use. And this is the concept of creative networks that I'm currently working on. That you need them. And in this context, there is a very interesting book that has really affected my thinking on this issue. It's called Guns, Germs, and Steel, and it sort of explains many of these technological advances in terms of the propagation, in terms of the interactions that are happening within different geographical areas, and digging deeper into history and why these things came to happen. Because we tend to prefer hero stories, right? James Watt invented the steam engine. This is what we say. But in reality, and even for all the other examples I mentioned in the previous section, in reality, this is what we consider the hero is just a link in a very long chain, right? So why do we prefer hero stories? Why? Well, it kind of makes sense, right? Because hero stories are easier. It's easy for me to remember one name than to remember all the different names that I just mentioned to you in the previous sections. So In reality, there are ecosystems of creativity, ecosystems of innovation, ecosystems of communication that are responsible for the production of these inventions and are responsible for the creation of the right conditions for the inventions to work. Right? And here I'm reminded by an example I always see. Somebody on social media will share a picture of a garage and will say, oh, in this garage IBM was done, in this garage Apple was done, in this garage Microsoft was started. What's stopping you? Right? And it's as if the garage is the magic ingredient. But if you dig a little bit deeper into the reality, it's not the garage, right? It's the network of investors. It's all the other companies who are creating patents and who Steve Jobs can walk into their office and take one patent and use it in an innovation and so on. There is always this system, and here I am reminded by a very subtle question that is posed in Guns, Germs, and Steel, and I will rephrase it in this manner. So, who is the hero? What does the hero do exactly? Does the hero find the right moment and hang to the coattails of history, or does the hero really shape history? Right. This is a very interesting duality to reflect on in the light of this discussion on heroes, systems, and networks. To conclude this discussion, there are three interesting themes that are present in these stories. The first theme is the hero versus the system, and we've seen that it is easier for us to think in terms of hero stories, to think in terms of heroes, to describe events in terms of heroes. And if we want to ask why, the answer isn't very difficult, right? Would people prefer easy stories, or would people prefer difficult and complex stories? Which would you prefer? Would you prefer emotionally touching stories, or stories filled with facts and dates? Okay, so this is approximate thinking at play, right? And it is so obvious why we would prefer hero stories. They are much easier to understand, much easier to memorize. But we have to remember that heroes are actually chains in a link, as we just said. But this takes us to the second theme, which we've seen in all the examples, and that is a theme of efficiency and improvement. So what is happening here is that this person who has achieved the great work, as we called it, has actually improved on something, and improved enough so that this thing is now practical to a wide group of people. And here we ask the question, how is technology born? Where are these inventions originally born? Is that as important as the moment in which we consider it to be great, in which we consider it to be capable of driving further social progress and economic progress, right? So we contrast radical and incremental innovation, and we look at creation versus adoption, and we look at the individual and the context around the individual. And remember our discussion on the true role of the hero. And finally, the final theme is we saw that these inventions actually have to be part of a plurality, okay? And this is always a theme in the Atlas of Worldly Wisdom, plurality. There have to be enough tries, enough attempts. And remember what we discussed about the networks in this context. So there have to be enough attempts so that Darwinistically the fittest will survive, right? So we ask the question, how do things accumulate enough till they reach the practical point? So we always talk about this. And so for things to accumulate enough, they need to happen within certain contexts, within dense networks of communication, networks of interaction, networks of cooperation, and even of transportation. And this has been the context of the Industrial Revolution and many of these inventions. From the moment in which they were perceived, which was back in history and didn't have enough practical application, till the moment in which they become truly useful and become acknowledged as a great work.